Hi guys, so today I'm going to be explaining the Geometry 3.8 quiz. So starting off with question 1, they're telling us in this question that a car travels from a station X to a station Y, which is 460 meters away on a bearing of 210 degrees. In this question, they want us to find the distance due west. Alright, so we're going to start by drawing a graph. There we go. And now we're gonna draw the bearing. So they told us that the bearing is 210 degrees. On this graph, each sector is worth 90 degrees. So that means that from this point till here, that's gonna be 90. Till here, it's gonna be 180. To here, it's 270. And then back up here, it's 360. Okay, now that we have that, we are going to draw our bearing. So the 210 degrees is going to be somewhere between 180 and 270. So we're going to start drawing our circle up until about here. And that's the bearing of 210 degrees. Now that we have that, we're going to look over here. And they told us that it goes from a station X to a station Y, which is 460 meters away. Okay, so we're gonna draw a line here like that, an arrow, and we're gonna label station X where it starts and station Y where it ends. And they told us that it's 460 meters away. Now that we have that, we need to find the distance due west. So the distance due west, so this is north, east, southwest. West goes in this direction. So now from here, we're going to draw a line in this direction, which will be our distance due west. Now to find the value of this green line, we're going to make this into a right angle by drawing a straight line perpendicular to the green line and adding a right angle here so that we can find the value of the green line. Now we need to have the value of the angle here so we can find the green line. So what we're going to do is 270 degrees minus 210 to get 60, which is the value of this angle. Now that we have that, we can find the value of our green line. So we're going to be using the cos rule to do that. So it's going to be cos equals the adjacent over the hypotenuse. Okay, now here the adjacent will be the green line. So the adjacent is the green line. So we're going to call it X. And the hypotenuse is over here, opposite to the right angle, 460 meters, 460. And the value of cos that we have is 60 degrees. We already have our angle, so it's going to be cos 60. Okay, now cos 60 is equal to 1/2. So that's going to be 1/2 is equal to X over 460. If you do cross multiplication like that, you're gonna get 230, which is our answer. Alright, so moving on to the second question. Here they told us that from a lighthouse, ship A is at a distance of 20 miles on a bearing of 20 degrees, and ship B is at a distance of 20 miles on a bearing of 260 degrees. Alright, so now we're gonna draw another graph. Alright, and we're gonna start off by drawing ship A. Here they told us the bearing of the ship is 20 degrees and it's at a distance of 20 miles. So we're gonna draw that. We already know here this is 0 degrees, 90, 180. This one's 270 degrees. Alright, so this is going to be between 0 degrees and 90 degrees. So the 20 degrees is going to be somewhere over there. And then we're going to draw, somewhere over here. Going to draw the arrow. And this arrow is 20 miles. And we're going to call this ship A. Alright, now that we have ship A, we're gonna move on and we're gonna draw ship B, which is on a bearing of 260 degrees and a distance of 20 miles as well. Alright, so ship B is gonna be somewhere between 180 degrees and 270 degrees. So we're gonna draw that like so. It's gonna be like about here. And now we're gonna draw it like so, and it's probably not that long. There we go. And this one's also 20 miles, and we're gonna label this as ship B. Alright, now they're asking us here to find the distance between the two ships. So I'm gonna draw a green line here, which is gonna be the distance between these two ships. Alright, now if we want to find the value of this green line, we're going to have to find the value of this angle here. Okay, so we don't know what this angle is, but we can find it because we have all the values we need to find it. So we're going to start off with this small angle here. To find this angle, we're going to do 270. 270 minus 260, which is the bearing, which will give us 10 degrees. This angle here, this is a right angle, so we automatically know this is 90 degrees. And then this one over here, we already know that this one is 20 degrees. Alright, so now we're going to add all of these up. So we're going to add up the 10 degrees and the 20 degrees and the 90 degrees. And that's going to be 90 plus 20 plus 10, which is going to give us 120. So now we know that this angle, this whole angle, is 120 degrees. Now I'm going to move this graph to the side and I'm going to redraw this triangle. Sorry. There we go. I'm going to move it over here and I'm going to redraw the triangle just so it's a little bit more clear and easy to understand. So that's sort of what our triangle looks like. Now we know that this angle is 120. We know that this side is 20 miles and we know that this side is also 20 miles. Now in this triangle, we can't apply the same rule that we used in the last one because it's not a right triangle. So what we have to apply here is sine rule. Sine rule is sine A over A is equal to sine B over B, and sine C over C. Okay, so that's what sine rule is, and we're gonna have to apply that here. But the problem is that we need to have these angles so that we can be able to apply sine rule. But we can find them. So we know in this entire triangle that the sum of the angles is 180. Alright, and we have this one, it's 20. And these two sides are equal. So that's going to mean that these two angles are also equal. So then what we're going to do here is we're going to do 180, which is the sum of all the angles, minus 120, which is the angle we have here, which is equal to 60. We're going to divide 60 by 2, which gives us 30 degrees. That means that these two angles are 30 degrees each. All right, now that we have this triangle, I'm going to move this up top. And we're going to apply the sine rule now so that we can find, we're going to name this side, which we don't know, x. All right, now we're going to apply the sine rule. So it's going to be sine 120 over x is equal to sine 30 over 20. We're going to do cross multiplication. Multiply these with each other. Going to get x is equal to sine 120 times 20 over sine 30. And then if you put that into a calculator, you're going to get that x is equal to 20 radical 3. They already gave us the radical 3, so you just put in a 20, and that's your answer. Okay, so now we're moving on to question number 3. Here they told us that the angle of elevation of a vertical tower, T, from a ship called S is 17 degrees. The ship is sailing 400 meters due east of the tower T, and they asked us to find the height of the tower in meters. Okay, so we're going to start off here by drawing the tower. So the tower is going to be this line here. That is the tower. And we're going to draw the ship over here, which is S. And the tower, they told us it is 400 meters due east of the ship, and this is in the eastward direction. And then they told us there's an angle of elevation of the vertical tower from a ship. So that means that this here, as they told us, 17 degrees. 17 degrees. Okay, now that we have that, we need to find the height of the tower. To find it, we're going to use the tangent rule. Since this is a right angle, we're going to use the tangent rule. So tan is equal to opposite over adjacent. Since we have the angle, since we have the angle and the adjacent, we can replace them. So we've got tan 17 degrees is equal to the opposite, which is the tower, over 400. All right, now we know that tan 17 is 0.31 as they gave us here. So we can replace that with 0.31 equals to opposite over 400. And we can do cross multiplication. This over 1, cross multiply. And you're going to get that opposite is equal to 400 times 0.31, which is 124. And that's the answer they gave you here. Okay, so moving on to this question, I'm going to start off by reading the given. So they told us that O is the center of the square BCDE, and A is vertically above O, N is the midpoint of the segment ED. And then they told us that BC is equal to CD, which is equal to DE, which is equal to BE, which is equal to 10. So all of these equal 10. And then AD equals AC equals AB equals AE equals 13. So all of these lines are equal to 13. So in part A, they're asking us to find AN. So let's go over here and let's look at AN. So that is this line over here. So what we can do here is we can turn this into a right triangle because AN is perpendicular to ED. So that means that over here we have a right triangle there. So what we can use here, since we have the measure of AE and we can find the measure of EN, we can use the Pythagorean theorem. But first, let's start by finding the measure of EN. So over here, they told us that GE is 10, okay? and we know that n is the midpoint of ED. So that means that n is half of ED, and half of ED would be 5. So that means that EN and ND are both 5. Okay, now we can use the Pythagorean theorem to find the value of AN. So what we're going to do here is the hypotenuse, which is AE squared, is equal to AN squared plus EN squared. And then we're going to rearrange this in a way that we can find AN. So then it's going to be AN squared is equal to AE squared minus EN squared. We're going to replace our values in this equation. So it's going to be AN squared is equal to 13 squared minus 5 squared. We can put a radical on both sides to cancel out the squared here. And then what you're going to get is, if you put that into your calculator, you're going to get 12. So AN is equal to 12. Alright, now I'm going to erase this and we're going to move on to part B. Okay, now in part B, they're asking you to, Now in part B, they're asking you to find the area of the face AED. So the face AED is this face over here. This is the face AED. Now they want you to find the total surface area of this face. So we know that in a triangle, the formula to find the area, so the area of a triangle is equal to 1/2 of the base times the height. Alright, so now we're just going to replace in this. So we know that the base is DE. It is 10. And then we also know that the height we got in the last question, that it's 12. So we just replace that. You're going to have 1/2 the base 10 times the height, which we got 12. And you're going to end up with 60. So that's going to be your answer here. Moving on to the next question. Here they're asking you to find the total surface area of the pyramid. Alright, so the total surface area of the pyramid. So let's look at what the pyramid is made out of. So you have one face here at the front, and then you've got one face over here. So that's 2 faces so far. There's one face back here, and then there's one here. So in total, we've got here 4 triangles. And keep in mind that all these triangles are all equal to each other. And then on the bottom, we've got a square. And then we have one square. Alright, so we already found the area of one of the triangles. So all we have to do is take this number and multiply it by 4 to get the area of all the triangles, of all 4 triangles. So what we're going to do to get this is 60, which is the area of one triangle, times 4. The answer to that is 240. And then the area of the square we have at the bottom. So the area of a square is always side squared. So you take one of these sides and you square it. So over here, it told us that the length of these sides they're all 10. So you're just gonna do 10 squared to get the surface area of the square. So that's going to be 100. So then you add these two together, it's going to be 240 plus 100. And then your total surface area is going to be 340. And that's the answer we've got here. And then Okay, so the last part of question 5 is a bit more complicated than the first three, but it's not too hard. So they're asking us to find the cosine of the angle between the two planes. The planes are EAD and BAC. Okay, so the plane EAD over here, this is the plane, and then right behind it, the plane BAC. So those are our two planes, and we need to find the angle between them. Okay, so if we want to find the angle between these two planes, first we need to find the plane that angle is on. So to do that, the first thing we're going to do is we're going to find the plane. So what I'm going to do here is I'm going to put a midpoint between B and C. And this midpoint, I'm going to call it N prime. Okay, and now I'm going to draw a plane like so. Now this plane, this is the plane between EAD and BAC, and this is the plane where our angle, this is the plane the angle's on, okay? So now the angle is over here. This is the angle that the question's asking us about. So this is the angle NAN prime, and this is the angle that we have to find. All right, now that we have the angle, they're asking us to find the cosine of this angle. This triangle isn't a right triangle, so we have to apply the cosine rules, which are a squared is equal to b squared plus c squared minus 2ab cosine a. This formula solves for a, which is a side. Right now we're not solving for a side, we're solving for an angle. So we directly apply the formula cosine A is equal to b squared plus c squared minus a squared over 2bc. This is the formula that we're going to use now. These two are both the same formulas, but the first one solves for a side, and the second one solves for an angle, which we're solving for right now, clearly. So we're going to find the values for this. We're going to find A, B, and C. So A is always going to be the side that's opposite to the angle. So here is our angle. So our A is going to be the side that's opposite to the angle. So our A is going to be this side, and then B and C are going to be the other two sides. Now let's replace into this formula. So it is cos A is equal to B squared. So that's going to be AN squared. AN squared minus C squared. So that's going to be AN prime squared. AN prime squared. And then, sorry, this is a plus. And then we're going to subtract A squared. And A is N prime minus N prime squared. Okay, now we're going to divide all of this by 2bc, which is b is an, and c is an prime. Okay, so now this is the formula that we're going to use. So now we're going to replace values into these. So we're going to start with B and C, so AN and AN prime. AN, we've already got the value of it, and AN prime is equal to AN. So the value of AN and AN prime is, both of them are 12, all right? So that's going to equal to 12 squared, because that's AN, plus 12 squared AN prime minus, now we have to find the value of A. So our A here is N prime, and if you look, then this side is equal to all of these sides, which are equal to 10. So that means that n prime, our side, that our A, is equal to 10. So then we do minus 10 squared, all of that over 2, 12 times 12. And then you're gonna put that into your calculator and you're gonna end up getting 47 over 72. And that's your answer here. Alright, so for this question, in part A, they're asking us to find the value of AH. Alright, so AH is this line here. And to find AH, what I'm going to do first is I'm going to draw a line here going from D until the midpoint of BC. And I'm going to call this point here point M. And point M is the midpoint of B and C. Okay, now that I have that, I'm going to try to find the value of dm. So it's going to be dm squared is equal to dc squared minus cm squared, Pythagorean theorem, which is equal to dc squared. They told us in the given that each edge length is 12 centimeters. So DC is going to be 12 centimeters, 12 squared, minus CM, which is here, this one. And we know that M is the midpoint of BC, so it splits BC directly in half. And BC, we know that it's 12, so CM is going to be 12 divided by 2, which is 6. So then we're going to do 6 squared. The answer you're going to get is that dm is equal to 6 radical 3. Okay, now that you have that, we're going to try to find dh, because look over here, I'm going to draw the base triangle. So this is the base triangle, BDC, and H is going to be right in the middle. This is H. So H is right in the middle of this base triangle. So that means that all the distances to H are the same from each side. Okay, so now what I'm going to do is find DH. So there's a rule that DH is equal to 2 over 3 of dm. Okay, so that's going to be, since we found dm here, dm, dh is going to be 2 over 3 times 6 radical 3, which is going to be 4 radical 3. 4 radical 3 dh. Okay, now that we found the value of dh, like I said here, all these sides are at the same distance from h. So that means that DH and BH and CH are all the same distance. So what I can do is draw a line here, turn this into a right triangle, and now I can solve for AH. So I'm going to do Pythagorean theorem again. AH squared is equal to AB squared minus BH squared. Okay, AB, we already know that it's 12 because each edge length is 12, minus BH. Like I said here, all of these are the same distance. So that means that BH is equal to DH, which is 4 radical 3. So minus 4 radical 3 squared, which is 4 radical 6. AH is 4 radical 6. And you're going to put a radical here, by the way. So AH, 4 radical 6. So then that's your answer here. They already gave you the radical 6, so you just put a 4. Alright, so now in part B, they're asking us to find the angle between AB and the plane BCD. Okay, so I'm gonna erase the stuff from the last question. Okay, so the angle between the line AB, which is this line here, and the plane BCD, which is the base. So technically we already have the triangle, and they're asking us for the angle B, and this is our hypotenuse. So now we just need to apply the sine rule because they told us to find the sine. So the sine rule is opposite over hypotenuse. So sine equals opposite over hypotenuse. The opposite here is AH, which we already found. So I'm just gonna write AH over the hypotenuse is AB, which we know because each edge length 12 centimeters. So BA. Okay, so now we can just replace our values. So we already know that AH is 4 radical 6, and we know that BA is 12. And then you're gonna get radical 6 over 3. They already gave you radical 6 over 3 here, so you're just gonna put a 1. Okay, so now moving on to the last part, they're telling us that if theta is the angle between any two faces, then sine theta is what? Okay, so they want us to take any two faces because all the faces are equal, and we need to find the angle between them. So we're gonna take the face ACD, which is this face here, and we're gonna take the base triangle, which is BCD, and we're gonna find the angle between it. So what we're gonna do here is first I'm gonna draw a midpoint between D and C, and I'm gonna call it point L. Now I'm gonna draw a line from H to L and the line AH and a line from A to L. And now this plane here is the plane between the two faces. So now that we have the plane, this is our right angle, and this angle here is the angle that we need to find. This is the angle between the two planes. Alright, now that we have this, we can find the values of two sides and we can apply the sine rule. So we already know that from the first part that AH is 4 radical 6. So AH here is 4 radical 6. And if you think about it, AL has the same measure as DM. This is the line DM that we found in the first part. And if you remember, DM is 6 radical 3. So now that we have these two sides, we can apply the sine rule and we can find the measure of angle L. So sine rule is opposite over hypotenuse, which is the opposite here, opposite to angle L is 4 radical 6. So 4 radical 6 over the hypotenuse, which is opposite to the right angle, 6 radical 3. 6 radical 3, and then you're gonna end up getting 2 radical 2 over 3, and they already gave you radical 2 over 3, so you just put in 2. Okay, so in the first part of this question, they're asking us to find AC. AC is this line here, and then we can use this triangle to find AC. So we know that this side is 8 and this one's 4, and that part of the angle here is 40 degrees. So if we want to solve for AC, we're gonna need this entire angle. Okay, so if you look here, then you're gonna notice that this here is a C shape, and according to the co-interior angle theorem, this plus, we're gonna call this angle X, add up to 180. So that means that 100 plus our angle X are equal to 180, which means that X equals to 80 degrees. Okay, now that we have our X, which we found is 80 degrees, okay, so now these two add up to find the full angle. So 80 plus 40 gives us 120. So now we know that this full angle is 120. Okay, now we have two sides and the included angle, so we can apply the cosine rule, which is a squared equals b squared plus c squared minus 2ab cos a. Okay, now we can replace our values. So it's going to be a squared is equal to b squared. So b can be 4. So 4 squared plus c squared, which is 8, plus 8 squared minus 2ab. So minus 2, 4, and 8 times cosine A. So A is the angle that we have, which we got 120. Cosine 120. And now we can solve this, and we're gonna get that A squared is equal to 112. We can put a radical on it, solve for just A. And then we're gonna get that A is equal to 4 radical 7. And then here they already gave us the radical 7, so we just put in a 4. Okay, so now for the second part, they're telling us that if sine angle CAB is equal to radical 21 over k, where k is an integer, then k is equal to what? Okay, so first let's see where angle CAB is. That is this angle here. This is angle CAB. So now to find the value of angle CAB, we can apply the sine rule, which is, if you don't know, sine A over A is equal to sine B over B equals to sine C over C. Okay, so sine A would be this angle. So sine A would be sine of angle CAB over the side opposite to it. So if we look here, the side opposite is 8. So we're going to do over 8 is equal to sine B over B. So B is this angle here, and we know that this is 80 plus 40, which is equal to 120 degrees. So sine 120 over B, which is the side opposite to that angle, which we got in the first part, AC equals 4 radical 7. We're going to do that over 4 radical 7. Okay, now that we have this, we can cross multiply, and that means that sine of angle CAB is equal to sine 120 times 8 over 4 radical 7. If you solve that, you're gonna get a radical 21 over 7. Here they gave you that the answer is 14, which is wrong. This is supposed to be 7. Okay, so here they're telling us that from the top of a cliff, the angle of depression of a boat at sea is 42 degrees, and that the horizontal distance of the boat from the foot of the cliff is 100 meters, and they're asking us to find the height of the cliff. Okay, so we're gonna start by drawing the cliff, which is a vertical line here, and we're gonna call it C. And now we're gonna draw the boat over here, which we're gonna call B. And they told us that the boat is at an angle of depression of 42 degrees. So this angle, 42 degrees. And they also told us that the horizontal distance of the boat from the foot of the cliff is 100 meters. So the foot of the cliff means the bottom of the cliff. So the horizontal distance is 100 meters. Now they want us to find the height of the cliff. So since this is a right triangle, we can apply the tan rule. So it's going to be tan equals to opposite over the adjacent. Okay, and we have the angle, so we have the tangent. So tan, the angle 42, tan 42 is equal to the opposite to the angle, just C, our unknown. So I'm just going to write C over the adjacent to the angle, which is 100. So 100. Okay, now in this table they told us that the value of tan 42 is 0.90. So we're going to replace tan 42 with 0.90. 0.90 equals to C over 100. You're going to cross multiply this over 1, cross multiply, and you're going to get that C is equal to 90, and that's the answer here. Here in this question, they want us to find the value of Z, and they told us that Y is 100. So we have Y told us it's 100, and we're going to start by finding the value of X, because we can't have more than one unknown. So to find the value of X, we're going to use this triangle, like so, and we're going to apply the tan rule to find the value of X. So it's going to be tan equals opposite over adjacent. We have the value of the angle, 45. It's going to be tan 45 equals to the opposite is X, our unknown. So it's going to be x over the adjacent is 100 over 100. And they told us here to use tan 45 equals to 1. So it's going to be 1 equals to x over 100, which is x equals 100. Now we got the value of our x, which is 100. Now we can try to solve for z. So we're going to use the full triangle to find so we're going to use the full triangle to try to find z. So we know that this angle is 27. So we're going to use the tangent rule again. So the rule is tan equals opposite over adjacent. We have our angle 27. So tan 27 equals to, the opposite is 100, and the adjacent, which is this line. Okay, so we don't have the value of the full line, but half of the line is 100, and we know that the full line would be 100 plus z. So we're going to put that here. So we're going to put 100 over 100 plus z. Okay, now we're going to cross multiply, but first we're going to replace tan 27 with 0.50. So I'm going to write over here 0.50 over 1 is equal to 100 over 100 plus z. Okay, now we can solve for z. Cross multiply. It's gonna be 100 is equal to 0.50 z plus 50. Can take 50 to the other side, and it's gonna be 0.50 z is equal to 50, and then you're going to divide both sides by 0.50, and you're going to get that z is equal to 100. Z equals 100, which is the answer here. For question 10, you're just going to do 90 minus 57, which gives you 33, which is the answer. Here you're going to do 360 minus 133, and you're going to get 227. And that's the answer. Here they want you to find the angle between the line PR and the plane QSR. So the line PR is this line here, and the plane QSR is this plane here. Okay, so first I'm gonna draw the plane between the line PR and the plane QSR. So that plane is gonna be like that. That's the plane between PR and QSR, and the angle is gonna be this angle here, which is angle PRM, and that's your answer, angle PRM. Okay, here you need to find the angle between the line QW and the plane PQRS. Okay, so the line QW is this line here, and the plane PQRS is this plane, and you need to find the angle between them. Okay, so we're gonna draw the plane first. So the plane between the line and the plane is this plane, sorry, like that. That's the plane, and then the angle between them is the angle over here. So this angle is the angle WQS. And that's it.